Hi, next we're going to look at some zero offset migration in a trace by trace sense using real data. The concepts used here can be extended to a pre-stack migration and in fact to any migration, and we'll talk about that later. Let's say that I'm a contractor who charges $10 per migrated trace. You send me a random trace and I migrate it. Here is the result. Now we have a section here, 2D section, with 500 traces, and you sent me trace 250 out of a possible 500 at this position here. We see that the migrated energy is spread out in 2D over a semicircular impulse response, as we've discussed in previous slides. These represent the possible original positions the energy could have reflected from in the subsurface. You might say, well, I can't interpret that. And I might respond, well, the migration is as good as we can get it, but why not send me some more traces? So now you start sending me more traces, and I migrate trace 180, and we get the same kind of result as before. Next, we look at the migration from 180 plus trace 110. Now we have two migrated traces. So we can still see the semicircular impulse responses, but we can also start to see that these wave fields are interfering. So we have a series in here of constructive interference and destructive interference. And the image is going to start to form as the possible constructive interference at the true reflector positions start to build up, and we get cancellation elsewhere. Now this might remind you of the movie we had earlier showing the interference between two sources and constructive and destructive interference. It's exactly the same concept. Anyway, we need more traces to form a good image. So you give me more traces and we start to build up the migration here. 5 traces. Let's move to 6, 7, 8, 9, and 10. And 10's a pretty nice round number. And we can see the full migration here of the 10 randomly selected traces. On the right-hand side of the section, we can see, now these were randomly selected, so on the right-hand side we can see the spacing is approximately the same, and we can still see very distinct impulse responses. In the center of the section, where we're just seeing a few traces quite close together here, we're starting to build an image in the subsurface, and you can start to see a zone of higher amplitude reflectors building up, sort of subhorizontal reflectors. Now it's a bit hard to see exactly at the moment, but we're starting to get the concept here that we're going to form this image by constructive interference, and we're going to get full destructive interference elsewhere. Now let's move on to a second scenario where we don't look at the results rather after each individual trace, but we look at results after randomly selecting groups of 10 traces. So here's the first migration after 10 traces. We can see an isolated trace out here to the left of the section and its semicircular impulse response. In the center here, we can see where we've got 2 traces quite close together. We're again starting to build an image, and but we need more traces. So that was 10 traces. This will be 20. Can start to see some flattish reflectors now building out to the left of the section. And in the center, we see this kind of confused zone and where no traces have been migrated, and the image is dominated by uncancelled impulse responses here and here. Now that's the kind of thing we sometimes see in real life. So say there was an obstruction at the surface, like a platform or an area exclusion zone that we weren't allowed to go into on land, a lake or something like that. So where we have poor surface sampling, we're going to get a poor image of the subsurface. So in this case, we do have those traces. So you notice that when we fill them in now, we're starting to build this image. I just toggle backwards and forwards. You can really see how the addition of just even 3 or 4 traces in there starts to form this image, and we're starting to see these subhorizontal reflectors coming through underneath all this background noise. So that's 30, 40, 50 traces. So that's 10% of the input data. We are actually starting to see the reflectors coming through. Let's carry on going. 70, 80, 90, another 100 traces. And remember, that's still only 20% of the total available. We're starting to see the reflectors really building quite nicely in the subsurface now. We've got a poor shallower image, but deeper down in this zone here, between 0.5 and 1 seconds, we're starting to see 2 or 3 coherent reflectors with gentle dips. Some small structure appearing in this zone here, and then our target reflector here at 1.5 seconds is also starting to become clear. So the next scenario will show the migration results in groups of 10 traces starting from the left of the image. So the migrated traces are not decimated here, unlike the random trace selection previously. So we should start to see how the full image quality builds up from the constructive and destructive interference between the migrated wave fields from individual traces. And exactly the same trace-by-trace algorithm is used to create the images. So from the first group of 10 traces, we can see the impulse response as we expect to the right, that hasn't been cancelled out yet. And there's nothing to the left here because there are no receivers up here. As we move into the next group of 10 traces, so 20 or 30, we're starting to see a good quality image now building up in the subsurface, 40 and 50. Now, one thing you will see is here we can see an uncancelled impulse response at 50 traces. As we move to the next group of traces, you see that original impulse response that was here. If I go back, I leave my cursor there, that uncancelled impulse response now kind of moves in this zone. So this one has been fully cancelled by the addition of the 10 traces. So on the far left of the section, the impulse responses are not fully cancelled. So these ones are never fully cancelled because we need energy from out here to be able to cancel these. And that's the so-called migration aperture. So we're not perfectly migrated and we don't have maximum resolution at the edge of the section. So I'll just carry on. That's 100 traces migrated. So again, we're seeing nice, good quality. These are the same reflectors we saw before, but now they stand out more. The signal to noise ratio is much higher. We have much less impulse response noise from the section. And 150 traces, 160, and I think we stop at 180 traces here. And I think I'll send you my bill now for about $2,000 for a migrated section. So slightly more seriously, and perhaps to justify my bill, you can see here that the section quality is really pretty good. We've got good quality images standing out in the subsurface, and all we really need to do is to migrate the rest of the section. So in the next slide, we'll look at how we use the semicircular smear method to collapse the fractions, and we'll start to look in more detail at how this migration might be implemented in practice.